Hey everyone, in this video I'm building another Eurorack case. I posted a video a while back where I built my big case using the Truggltronics M15 power supply. This time I'm going to build a smaller case using the Konstant Lab's Hammer power supply. There are of course tons of options with power supplies, and it's one of the most important decisions that you have to make when you're building a case. I've been learning a ton about power and all the different features and types that you can get in Eurorack cases, and I'm really excited to share what I've learned with all of you. As a part of all this research, I spent a lot of time asking questions on forums and reading forums, and it seems like Konstant Lab's stuff continually comes up as a premium power supply. So I reached out to them to see if they wanted to sponsor a video, and they sent me the Hammer power supply kit. So thanks Konstant Lab, I really appreciate it. Now, I don't think it's possible to really say this one power supply is superior to all the other power supplies out there. It's a really personal choice, and it depends on how you want to use your case, what features and aspects you want to prioritize, and it's really different for everybody. And although I'm going to be building this case using Konstant Lab's Hammer, I do want to focus on the decision-making process so that you can use that information to decide what power supply is right for you. Just a little disclaimer, I'm not an electrical engineer or an expert in any way. I've just done a lot of research and I want to share out what I've learned. If you are, make sure to leave some comments. Let us know what you think of the video, or if there's anything that I missed. I always like to learn, and I'm sure that there are other people who would really appreciate as much information as possible. If you're interested in DIY building or Eurorack in general, make sure to hit that subscribe button. I'd really appreciate it. Also, check out my Patreon page. I give away a DIY module once a month. It's a great way to support my channel and just be a part of the fun. So, okay, with that out of the way, let's dig in. First of all, let's go over some power supply basics. A good place to start is linear versus switching supplies. Let's make sure we're clear on the essential information here. The ins and outs aren't as important, but there are some main points that I really want to emphasize. Linear and switching power supplies are two common types of DC power supplies in electronics. Each has its own method for converting alternating current, AC, into direct current, DC. And both have advantages and disadvantages. You can get linear power supplies for Eurorack and switching power supplies for Eurorack. For instance, Konstant Labs has a linear power supply, the ZD-ROJ. The Hammer, however, is a switching power supply. So let's take a look at the difference. Linear power supplies convert AC to DC using a transformer to step down the voltage to a desired level. They then use a rectifier and a filter to smooth the voltage and a voltage regulator to maintain a constant output. Switching power supplies, however, convert AC to DC by chopping the input AC power into high frequency pulses. It's done using a high-speed switching transistor. And the resulting high-frequency AC is then stepped down, rectified, and filtered to produce the final DC output. Okay, so it's okay if you don't fully understand that, but here's why it matters. Because the transformer operates at a much higher frequency than AC power, switching power supplies use smaller transformers and components, making them more compact and lightweight. They're also cheaper than linear power supplies because of the specific components they use. So that's all great, except for the switching process generates higher levels of electronic noise and ripple compared to linear supplies. When I say noise here, I'm not talking about like a noise module like white noise or pink noise. It's really about electrical disturbances to the signal. And how can that impact things? First of all, fluctuations in voltage can cause unwanted distortions to the signal, and that could cause distortions in the audio signal. It can make tuning issues, and it can also cause timing issues. There are different types of electronical noise too. Here's an example of ripple noise. Now you can see if we zoom in on the signal, it's distorted and it won't produce a clean sound. Another type of noise is called common noise. Common noise can disrupt signals or even generate an audible hum or buzz. This chart shows a waveform of common mode noise of a standard switching power supply. Linear supplies, on the other hand, have very low ripple and noise, which makes them excellent for audio and sensitive equipment. So you would think that that makes linear supplies just the superior Eurorack standard, and that's what we should all use, right? Well, not exactly, although there is an argument there. The thing is that linear power supplies, I already mentioned, cost more than switching power supplies. They're also not as efficient, so they're gonna be hotter. You're gonna wanna make sure that your rack at least has some type of venting or something, but you wanna be careful of the amount of heat it produces. Lastly, they're bigger and they're heavier. So if you're building a travel case or you have just a small skiff, it's not really gonna work out for you. And that's why I say it really depends on your priorities and that there's not really one right answer. With meticulous filtering and regulating, switching supplies can get extremely close to the stability and clean signal of a linear supply. So if you want that efficiency, size, power, and a cheaper cost that comes with a switching supply, but you don't want all that noise, you're gonna wanna make sure that it's engineered and built with all those considerations in mind. And it's important to note that not all switching supplies are made equal. And that's what brings me to Konstant Labs. And that's what I found when I was researching them. That's why I reached out to them, was that it seems like they really understand those concerns and have addressed them in their build. For instance, they have dual input common mode LC filters. Those filters effectively cancel noise and interference from the input connector, and it directly addresses that common mode noise that I was talking about earlier, that audible hum. There's also additional input filters for each converter. Those minimize output noise and interference. And if you use their bus boards, there's a ton of filters on those as well. So really, they've done a great job of giving you kind of the best of both worlds and creating a switching supply, but also filtering it in ways that addresses all of the different types of noise that you could get with a switching power supply. So I was tempted by some of the switching supply kits out there. I use Modular Synth Lab a lot. I bought my rails that I'm gonna use on this build from them. And they have these Meanwell kits, and they are dirt cheap, they have a ton of power, and that's actually what got me started down this road. And those are fine, and honestly, if the difference between being able to afford building a case, it means you have to get a Meanwell power supply, I would go ahead and do it. But you know, they'll definitely work, but you can expect some of the interference and electronical noise that I was talking about. But Konstant Labs does offer some additional features and protections. There's protection against input overvoltage. There's input reverse polarity voltage protection, output overvoltage protection, output short circuit. So basically they have a ton of protections to protect your modules and your case. So there's always a big range, but I think I mentioned earlier that they do actually have linear supplies as well. So if you are dead set on getting the cleanest power possible as your top priority, you can check out their stuff. The ZDRO-J is looks like a great power supply, but the Hammer seemed perfect for what I want to do, and it was just that right balance of cost, and I'm okay with the switching power supply. So excited to try it out. So okay, that's the basics of power. That's how I came to find Konstant Lab's Hammer power supply, and that's what we're gonna do today. So, okay, let's move on to the build. Okay, so the first step should always be to plan a little bit. I chose to build this case with 4 rows of 114 HP. I went onto Modular Grid and made a case filled with some of my heaviest power consumers, and then added in some popular modules that have heavy power consumption. Now, realistically, I probably could have gone a bit bigger. The Hammer will leave me a ton of headroom. It gives 5,000 milliamps at the positive 12 volt rail. It gives 2,500 milliamps at the negative 12 volt rail, and 2,000 milliamps at the positive 5 volt rail. A good general rule of thumb is to stay under 80% of your total power max. I'm hovering right around 60%. So that's my plan. Let's take a quick trip out of my studio and into my wood shop so I can show you how I constructed the case. Okay, so I'm in my wood shop and I just want to talk a little bit about how I'm going to construct the box. I made these ears, which is similar to how I made my bigger one. And that's what I'm going to be using to as the sides of this case. So as I said before, it's going to be 114 HP. I drilled in holes here to match where the screws are, and I'm just going to, or where the rails would go, and I'm just going to put screws right into each hole. I like doing it this way because I just think it makes it easier. I cut this plywood piece to exactly the same length as a 114 HP rail. And now all I have to do is cut off pieces that basically match the bottom of the ears in width because the length is right, and then I'm going to attach them that way. So I can just cut off a piece for the bottom, a piece for the front, a piece for the top, and then some pieces for the sides for the bus boards to be mounted on. So that is how I'm going to construct it. I'm going to go ahead and cut the pieces, and then I'll show you what it's like when I'm all done. Okay, so I've got all my pieces cut. As you can see, let's just walk through them. So those are the ears, of course, just matching. And then this is going to be the bottom right here. And I cut these little pocket holes in here using a Craig pocket hole jig. But you could just go through the side, but this way there won't be any visible nails or screws on the side. And as you can see, it's just a little bit shorter than the width of the case, but that's to allow a front piece, and then it doesn't really matter on the back. So I just kind of cut it at a round number. So it's gonna be standing up like that. These pieces are gonna go throughout for the baseboard, for the bus boards to sit on. And then I've also got a couple of these pieces for the top and the bottom. I did put some edge banding on here so that it will be a smooth edge and so that the sides of the plywood doesn't show. That way, if you paint it, it'll be really cool. But what's nice about constructing it this way is that really all the pieces are the same exact length. So you just cut the ears to whatever shape you want for your system. And then the bottom and all the bus boards and everything, they're all the exact same length. So now all I have to do is screw everything together, and then I can install the power supply. So I'm gonna go ahead and do that, and I'll show you what it looks like when it's all done. Okay, so this is what the case looks like all put together. You can see I just used those boards and screwed them directly in with pocket screws, and you can see the rail fits perfectly in there. I left some spaces open on the back just for heat and airflow. Plus, once this is all filled up with modules, you won't see it, so I figured it might as well save some material and just leave that open. All right, so I'm gonna bring this back into my studio and we can start installing the power supply. Okay, so I got my case right here, and right now I'm just gonna lay everything out and see how I wanna put it together, but I also wanna show you what comes with the kit. So first of all, you get this bezel with the on-off switch. That's where you plug your power brick into. Both of these come with it. So I just drilled a little hole in the side of my case right here. It's a little square about 1.5 inches by 1 inch or so, and that's where that's gonna fit in. So that's where the on-off switch will be. You of course get the power supply, and I just wanna highlight how small this thing is. It fits in the palm of my hand. It's roughly, I don't know, about 1 inch tall. So, I mean, 1/2 inch tall, so it's skiff friendly, very well built. That's gonna go back here. And again, I'm just laying everything out. With the kit, you get 4 bus boards. There's 2 different kinds. I have couple of each, but there are the straight connectors like this one, where the connectors are pointing straight up. But if you are building something that doesn't have much depth, you can get these angled connectors where your modules would plug in that way. There are a few less inputs or connection points on the angled connectors, but there's still a lot of them. These are those filters I was talking about earlier. So there's a ton of them there. And that's really what provides that stability to your analog modules. You can see on the back that this side is direct and this side is filtered. So you just want to make sure that if you are going to be really focused on the filtering side, you're going to want to put it in such a way that your analog modules or the sensitive modules get plugged in here. So how I'm going to lay mine out is I'll have the angled connectors go at the bottom and the top, right up here. Hope you can see that. And then I'll have a straight connector go here and a straight connector go here because there's a lot more room in this particular setup. So you also get these standoffs and screws. These will keep the bus boards and the power supply above the actual plywood, so just keeps everything safe. And then lastly, you get some wire to wire everything together, and just some handy little ties to keep everything organized. Okay, so I'm gonna lay everything out. I think the most important part is how it's all wired together. So I'm just gonna go ahead and stop the video, lay things out. I mean, it's pretty straightforward. You just, when you're using these standoffs, you just put the standoff underneath the hole and then screw through it and it stays wherever you put it. So I'm gonna go ahead and stop the video and do that. And then once I have everything in its place, I'll show you how it's all wired up. Okay, I've got everything hooked up to the case, and now all I have to do is wire it together. So here's the wiring diagram. So I did do mine kind of as a mirror image, but you just want to make sure that the wires coming out of here match up with the voltages, and it's listed right on the board. So it's pretty hard to mess up, but just be careful because I've done things like that. So these connectors here on the power supply, are very hard to push down. You probably have to use like a screwdriver or something to push these down to get the power cable in. But it's pretty straightforward anyway, so I'm just gonna go ahead and do that. Push it all the way down. You can stick it in from the top, make sure it goes in all the way, let go, and then you can tell, you know, if it fits snug in there. Okay, so that's what it looks like when it's all together. And let's turn it on. And there you go. So those LEDs show us that it is working. There is power coming to it. And yeah, so now all we have to do is wire up our bus boards. It is a little bit confusing because I wish that they had color coded these to match these. But it's pretty straightforward from the wiring diagram. The black one would go into this first one. Orange, white, blue, and orange, white, blue. So it just kind of goes in order. And what's great is that, you know, they have these LEDs too. So once you wire it up, you're going to know whether or not you did it correctly. So you need some of these. The wires that they give you are 16 gauge. So just make sure that on your wire cutters, you have a 16 gauge wire stripper. And yeah, so let's do that. All right, so I'm going to start with the black one. I, of course, don't need a whole lot of cable, so I'm gonna give myself a little bit extra just in case I make a mistake. So can you see this? I hope so. So I'm gonna cut it, and I'm gonna use my 16 gauge strippers, pull off about that much. That one's in there tight. And those are super easy and smooth to push them in. So there you go. I have my first wire hooked up. I'm gonna hook up these three in the same manner, and then we'll test it out. We'll turn it on and see if those LEDs come out, and then we can just daisy chain these together, and then we'll run the other side up to the top. So let me just wire those other three up. All right, so everything is wired up, as you can see, and I'm gonna turn it on and see if everything looks like it's working. And there you go. All the LEDs are on, which indicates that I've wired everything correctly. Now all I have left to do is put in the rails or the racks and then fill it with modules. So I'm gonna go ahead and do that now, and we'll see what it looks like all put together. So here it is. Here's my new case. It's all wired up. So everything works great and I'm pretty happy with it. So overall, this was a really easy build. The kit makes it super simple. If you are planning on building your own case, I'd definitely check out Konstant Lab stuff. If you use their power supplies or have any other information that you want to add to this video, make sure to let us know down in the comments section. I always really appreciate the comments that I get. Don't forget to subscribe, check out my Patreon page. Thanks again, Konstant Labs, for sponsoring the video. And thanks for watching. I'll see you next time.